Hey, everybody. Welcome to Daniel Davis Deep Dive. Always appreciate you guys coming out to. We have a little bit of a different show today than we typically do. And I'm really eager to get into this one. We had Ted Postol on not long ago, shortly after Iran had attacked Israel. And we had him on, as we often do after these kinds of situations, to provide some expert analysis of what we actually saw with the missiles, how many were intercepted, what was their performance on the ground, et cetera. And after that last show, we had a number of people who called in or wrote in with their comments and said, "Hey, what about this? What about that?" Well, we had a lot of them, and so we discussed it with Professor Postol. And we said, "Hey, would you be willing to come back on and kind of answer some of the questions we have? Because we pay attention to your questions. We really do." And he very graciously decided or agreed to come back on, and actually has done quite a bit of work. And as you can see from his location here, he's not in his normal spot. He's took the time out of a trip to Berlin. So this is coming to you live from Berlin, Germany. So we really appreciate you taking the time to come and do this and to just kind of answer some of the questions some of our folks have and give us all a better education.
Well,
so
I'm very happy to do it. I'm very happy to do it. This is an interesting subject, actually. There's a lot more to it than people realize. And people often think they know more than they do.
They did, and that's why we want it, because some of us we don't know what we don't know. We kind of think, well, this seems right to us or whatever. I certainly fell into that trap a little bit by some of the things I saw on the ground, and I thought, well, maybe this is the case. But as you're going to show us here, some of the issues are not quite what it seems to a layman, like I am. And one of a bunch of the clump of questions had to do with the CEP, the circular error probability, I think is what it stands for. So I wonder, first of all, if you can kind of go through a little bit and explain to us what the CEP means, and is it 2.2 kilometers? Is it something different? And what did you conclude?
And Ted, could you tilt your camera down just a little bit for us? Get rid of some of that headroom. Beautiful.
Okay, great. Thank you. Well, why don't we start with slide 3, just so we have something for people to look at. And slide 3 shows the Monterey Institute's effort to identify impact points from satellite imagery. It may or may not be very accurate, but it's good enough within the uncertainties. And if we go to the next slide, we can see how I sort of made a very rough guess of what the accuracy of the incoming warheads could be, assuming that there was a single aim point. That is to say, at the center of the airfield. Now, the airfield is the circle that's drawn there is a little bit over 4 kilometers in diameter, and there are only 32 hit points. And for people who understand statistics, you'd understand quite quickly that a statistical distribution like this is, for a small number of points, will have clumping of all kinds. So some of the people raise questions about, if you look in the lower right, there's an area of clumps. In fact, there are 3 impact points very close together around the shelter, where one of the impact points actually went through the top of a shelter. And some people thought that was an indication of a high accuracy attack. If you look to the left of that, the left lower corner, you see a bunch of impacts in an open area where there's nothing. Why would you, if you had the precision to attack it, why would you do that? If you really had precision, you would expect the clusters to be at the lower right, maybe diagonally upward from that area where you see some buildings, where you see some hits. Toward the very top, you see a cluster of 3 again. But looking at this, if you look at the statistical uncertainties that occur when you just have random events occurring, you know that there will be what we call clumping events. And what I actually did, if we jump to slide 6, is I took that circle of about 4 kilometers, and I said, well, that circle is probably roughly twice the CEP. CEP is defined as a circle within which half of the objects that if you shoot at an aim point, half of the objects will be within the CEP, and the other half will be outside the CEP. So in the next circle, there'll be maybe another 30% of the hit points, and then in the circle beyond that, there'll be a few more. If you just want to get a sense of what this looks like, the next slide, slide 7, I did some computer experiments to illustrate this. So these are computer experiments. What you simply do is you generate random numbers that follow a statistical distribution known as a Gaussian, which everybody agrees is going to be roughly what the impact points, how the impact points from a missile are going to be distributed. The size of the Gaussian and the source of the errors, which I'll talk about somewhat later, differ quite a bit. So if you look at the first row, you see there are 4 separate experiments, and you see there are open areas and clusters that are different in each one of the 4 areas. If you look at the next row down, what I've assumed is 4 aim points, pretty much like some people have suggested. And in those aim points, since there are 32 impacts altogether, I did a statistical statistical experiments around each of the 4 aim points, assuming a 500 meter CEP. And you see that is plausibly somewhat like what we saw in the in the actual data, but the aim points could be closer in or further out, or the accuracy could be better, that larger than 500 meters. There's really no way of distinguishing between the bottom row with any certainty and the top row with any certainty, because we just don't have enough numbers. Some people claimed the accuracy was much higher, like 200 meters. And the experiment at the last row clearly shows that that cannot be the case. That's a 250 meter CEP. A 200 meter CEP would you'd have very well defined clusters. And of course, 1 to 2 of those clusters, basically 2 of the clusters, would be on empty space. So you'd have to ask yourself, why would an adversary choose 2 aim points that are basically where there are no targets inside them?
Yeah.
So this is not proof. I want to be very clear. This is not proof. What I'm saying is it's not knowable with the data that we have. That is to say, with the number of hit points and the number of attempts to hit targets that were made. What is knowable is that the accuracy is probably somewhere between 500 and 1,000 meters. And my guess is it's actually about 1,000 meters. So it's just my guess from having looked at these things over many years and reached conclusions that later turned out to be right or wrong. And it's too much to worry too much about these differences is like worrying about how many angels can dance on the head of a pin. So the question is the difference between a 500 meter and a 1,000 meter CEP, does it tell you, is there something you can do militarily with, for example, within the uncertainty, with the 500 meter CEP relative to a 1,000 meter CEP that makes these missiles somehow more useful militarily? And as I'll show you, the answer is no. In other words, if their accuracy is somewhere between 500 and 1,000 meters, they're going to be able to do certain things and not be able to do other things. And most of it is basically controlled by the damage radius. In other words, if they were nuclear weapons, 1,000 meter or 500 meter would destroy the whole base. So that would solve the problem. But if their damage radii are closer to 100 meters or 50 meters, which I'll show you is really what the case is, and you have only 30 of them falling, the kind of damage you can do and the kind of missions you can hope to accomplish are roughly the same. You can do somewhat better or somewhat worse, but there's no sudden capability that emerges if you have this uncertainty. So a question that's interesting to ask is, what are the sources? What are the technical uncertainties, the technical parameters that the missileer tries to control that gives you, that leads to an impact distribution at the target? And of course, the most obvious and simple one, but it will turn out not to be true, incidentally, I'm going to warn you right now, is the burnout parameters of the missile. So in slide 10 here, I just show you a situation for a 1,000 kilometer range ballistic missile warhead. Somebody asked me about the speeds. Somebody said that ballistic missiles can't travel at 200 meters per second. So, the speed of a ballistic missile is determined by its range, if we're just talking about. So if the ballistic missile is traveling 1,000 kilometers, and let's not worry about air drag, and I just think of it from a launch point that's 0 on the left, flying to an impact point at 1,000 kilometers range with no aerodynamic drag playing a role, the speed is going to be about 3 kilometers per second at launch and at impact. And that's what you're going to get. It's just determined by the pull of gravity and Kepler's laws of physics. Now, what actually happens is the ballistic missile only flies to maybe an altitude of 100 kilometers during its powered flight. So because it burns out at 100 kilometers, its actual burnout speed is around 2.5 or 2.6 kilometers per second, because it's on a point in the trajectory where it's not flying from the ground. So a lot of the gravitational pull that it would have to overtake, it's already done while flying to its burnout point. So if we ask, what is a plus or minus 1 kilometer miss at the target going to do, it turns out that if it's plus or minus 4 meters per second, roughly 3 or 4 meters per second, faster or slower than 2.5 kilometers per second, it's going to fall roughly 1,000 meters long or 1,000 meters short of the impact point, of the intended impact point. So it's 4 meters out of 4 thousandths of a kilometer out of 2.65 kilometers per second. So, you really need a lot of precision in your burnout control. So that's hard to get. Then what would its loft angle be at burnout? It should be around 34 or 35 degrees. But that loft angle better be accurate to about 3/100ths of a degree, 2 or 3/100ths of a degree. Otherwise, in other words, if you have exactly the right velocity and you're 2 or 3/100ths of a degree off, then you're going to fall plus or minus 1 kilometer from the intended aim point. So you really need to have a lot of precise control at burnout. And that's not easy to do. It doesn't matter who you are. It's a demanding task. So when someone says, "Well, these are, the technology has changed in how many years, and You're talking about 300-kilometer Scuds versus 600-kilometer Scuds, because they're 600-kilometer range Scuds, versus 1,000-kilometer range ballistic missiles, which are really derived from technologies very similar to that of the Scud. So a lot of the control parameters are similar, not the same, but similar. There's not a lot of dramatic changes you're going to see. But let's talk about another factor that plays a big role equal to that of the burnout parameters. That's also very hard for the ballistic missile attacker to control. So let's go to slide 13. I'll show you something that we learned during the Gulf War of 1991. So that was 35 years ago.
Now, by the way, you're going to be talking about like the warhead breakups in this section, right?
Yes.
Yeah, and I wonder if you could talk about that, and Gary, if you have any of those B-rolls to could show, because some of the images that were shown of that the last Iranian strike, you see lots of dots coming down, then you see trails coming off behind some of them. Some people were saying those were the ones that were intercepted. They were damaged by the interceptors too. So I wonder if you can talk about the difference between something that was intercepted and something that's breaking up.
Yeah, well, first of all, you would see interceptors in the air. You don't necessarily see the interceptors when they try to make an intercept, because the way a typical interceptor burns, it'll have a short flight time. It accelerates up to a speed. In the case of, let's say, Patriot, let's just talk specifically. Patriot takes about 12 seconds to achieve a speed of about 1.5 kilometers per second. Then it's no longer burning. It's no longer in powered flight, but it flies by developing an angle of attack in the atmosphere and maneuvers with that angle of attack. I'll show you some diagrams later, and I'll show you some images as well. And so you can't see the missile after it has finished its powered flight. But what you can see is the detonation of its warhead. And if the detonation of its warhead causes the detonation of the warhead in the ballistic missile, you'll get a very large fireball in the sky. Otherwise, you get a small fireball, because the warhead on the Patriot is very small relative to the fireball in the incoming missiles. And it would be a very distinct event. And we showed that in the, there you go. There's one right there. And this is the same fireball seen from two different cameras, as it turns out. And this is either an intercept or a failed fusing. And my guess, it's an actual intercept, probably with an iron dome. A low altitude intercept with an iron dome, probably. Could be wrong. It could just be an accidental detonation of the warhead. We cannot determine that from this image. But the image is telling you what a large and distinct fireball you're going to see relative to these other small dots. So what happens as these missiles fly to an altitude, if you look at the higher of the two curves, the lower curve is actually a Scud ballistic missile that would go out at 300, would impact at 300 kilometers range. The upper curve shows the fly-out trajectory of an Al Hussein ballistic. This is an Iraqi missile, which was a Scud ballistic missile that was lengthened to fly along. It had about 20% more fuel and a lighter warhead. And so it burns out at 50 kilometers. You see the green dot, rather than at 30 kilometers. Now that seems like nothing. Seems like no. But if you actually look at the density of air at 50 kilometers, the density of air is so much lower at 50 kilometers that if that Scud missile has a little bit of rotation, it's going to continue rotating as it rises out of the atmosphere, because the fins on the back, like the feathers on an arrow that's being flying from a bow, do not have enough air to stabilize the arrow, or in this case, the rocket. So what happened, and this happened throughout the Gulf War, and was also happening to a lesser extent, but also in the case of the Iranian ballistic missiles, is that one way to think of it, if you look at my fingers here, is I'm accelerating. I'm accelerating the missile. I'm accelerating the missile with the end of. Here's the missile, and I'm pushing it with my finger. So as I push it, I'm trying to guide it to get the exact right angle at burnout. Now, when the rocket motor burns out, I may have inadvertently given it a little rotational motion. Now, if it's low enough in the atmosphere, it has fins on it, and the fins cause it to stabilize, which happens with the Scud B. You don't see Scud Bs tumbling. But if you see Al Hussein's, which are also Scuds, they burn out at a higher altitude, only a slightly higher altitude, and they tumble at high altitude. So if we look at slide 15, if you look at slide 15, what actually occurred is the Scuds were tumbling at high altitudes. And when they came into the atmosphere, if you look at the right side of the cartoon, the sometimes they were oriented correctly. So when they hit the top of the atmosphere, they were pointing roughly into the atmosphere. So they wobble around, and I'll show you, can break up even then. Or in many cases, they literally belly flopped into the atmosphere in the case of the Al Hussein Scuds in the Gulf War of 1991, and they broke up. And the places they tend to break up are the back end tends to break off, in other words, where the rocket motor assembly is, and the oxidizer and fuel tanks can break away from each other. And when you see Scuds on the ground, or even Iranian missiles on the ground, sometimes you'll see them in one whole piece. Sometimes you'll see a fuel tank. Sometimes you'll see an oxidizer tank. Sometimes you'll see a rocket motor. And so you're seeing the same thing. Now, in the case of the Iranian missiles, they're on a trajectory for 8 full minutes because they're traveling 1,000 kilometers. If you're there you go. There's a fuel tank and an oxidizer tank. So what happens when if we look at slide 18, when these misoriented missiles come into the atmosphere, they tend to spiral. And when they're spiraling, they're undergoing very extreme lateral accelerations. These spirals, keep in mind that this missile is a thin shell filled with propellant, mostly liquid propellant, these ones now. And, they're not very rigid once the fuel has been consumed, and they're suffering very high lateral accelerations. So if you look at the next slide in that cartoon, these things can tend to break up. And in fact, those pieces that break up can be very luminous because they're traveling at high speed. At 2 kilometers per second, they're luminous. At 3 kilometers per second, they're even more luminous. So because they're heated by friction in the air and compression of air in front of them. So if we go to slide 21, we have a very nice image that we happened to get by accident. This is a 34-year-old image. It's a video frame. It's one video. This was caught on a video. And what you see in this video frame is a trail that's about 1.6 seconds long. I say seconds. So this trail was generated by pieces of metal or paint that were bubbling off the body of this Scud missile and remaining luminous in the air. When those pieces of luminous dust came off, they stopped instantly in the air, and And the benefit for us, since it was at night, is it left a trail which allowed us in this one time image to see the spiraling motion. So pretty extraordinary. And in this particular case, I've labeled the different points of different events. You see this bulbous thing at the bottom of this luminous spiral. That is the scud just breaking up. It just breaks fuel, remaining fuels coming out, and you see it looks almost like a spider. Things are coming off. Pieces, fragments that are big, fragments that are small. If you see there are two large fingers sort of at the lower end of this image. And those fingers, I'm quite sure, are fuel tanks, fuel and oxidizer tanks that come off. And you see bright objects as well. Those are big pieces of something that are coming off. And they slow down very fast. So because they slow down so fast, they no longer are luminous, because those pieces hit the ground at 100 miles per hour.
Yeah. So let me see if I'm understanding correctly, because even when some of this happens, like when the fuel tank, whatever, it disintegrates, the warhead itself is still valid and active, right? Or at least in some cases.
Yes. And if you look,
and I wonder if you could go to, I think on slide 31, you start to talk about some of the challenges to intercept these missiles, because they still have to be, the warheads have to be intercepted.
Right. You have to hit the warhead, and it doesn't help you much if you're hitting the body of the missile. Well, here is slide 32 that follows this shows you more images of breakups of missiles. All right, the upper left curve is the one we were looking at earlier in its flight. So this is a video frame of what you saw earlier, of what you saw in the earlier slide, but before it's beginning its spiral. And you see this bright ball of light. That was a Patriot interceptor that literally missed it. And if you imagine that the Patriot interceptor was aiming at the upper top section of that luminous spiral, it was like the missile took an evasive maneuver. You could even almost think of the missile taking an evasive maneuver that caught the Patriot without, like an open field tackle, where the runner takes a lateral thrust all of a sudden against you, and you miss the. So in this case, now you could think that this was intended. This is an accident. It's an accident of the engagement. The Patriot was homing on the Scud, and Scud took a turn because it was wobbling, and complete miss. Now, if you look at the image directly below, that's the same engagement. If you look, the spiral is now further down because things are going further. And if you look, there are three objects clustered below this breakup cloud, which actually includes the explosion of a Patriot interceptor, which you can't see in this, but I was going to show you the video, but I just only had so much time, because there's a video of this that I could show you some other time if people are crazy enough to want to see it. And what happened in this particular case is the Scud broke up at about the instant that the Patriot was finishing homing on the Scud. And the Scud and so what the Patriot interceptor was seeing was a target, and all of a sudden the target became a bunch of targets because the Scud just broke up. This was all an accident of circumstance. And what you're seeing now below that breakup and a fireball that's mixed in there from the Patriot, you're also seeing three objects, one of which we know is the warhead, because we followed it to the ground and it exploded. We could not tell it was the warhead from this image. But if we went back, for example, to slide 22, that's the Scud warhead that I showed you in the last slide. Scudding to the ground, you see the impact in the next slide, and you see the fire. So we know it was the warhead. So if we go back to 32 again, we can again see that this object was the Scud warhead, but then look at the upper right, which is a different event. What happened here is this Scud was, you can see that it was taking a lateral turn. It wasn't traveling straight. That's because the missile body had an angle of attack relative to its direction of motion. So it was laterally accelerating, just like a Patriot interceptor might. And if we go back to the slide, and it just broke up because the forces, it has no bending strength. And what you're seeing now is a spiraling motion of the warhead. But you see that the warhead is tumbling, and it too generates enough lift to cause it to, perform lateral accelerations.
So let me ask you. So this is, as you pointed out, 1991 technology, both in the missiles, well, actually a little older than that, and the interceptors. What about today? What we're observing, in these shots coming in from Iran, et cetera. Do you still have the same dynamics?
You're seeing basically similar phenomena. You're seeing similar phenomena. Yes, things are breaking up now. In this particular case, I don't think you're seeing breakups. I think you're seeing warheads at this point. You're looking at objects coming in at low altitude toward the airbase. And my assumption, somebody asked about this assumption actually in the question. My assumption is all of the missiles we're seeing in this, essentially all, are modern missiles which have separated warheads. The warheads separated at higher altitudes from the main bodies. So we're actually seeing warheads come in. More modern
when you say warheads and they separated from the body, just in the light that we see, is that from friction, or does it have a separate motor at the end?
No. The light you're seeing is from friction, and things are boiling over. You're just seeing the breakup of older missiles. And
so
it's
now,
just
to your knowledge, does Iran have? Do you know how many of the more modern missiles that might not break up that they have in their inventory?
Well, I think there was a bunch of the more modern missiles went into the airbase. They shot at the airbase with a mix of missiles, but it looked to me like most of the missiles in the low altitude images we had of arriving warheads, it looked to me like most of them were behaving in a similar way. You're not seeing lots of different.
I think you said that there were 32 impact points.
Well, we saw 32 impacts. We don't know that there weren't. So there might have been some older missiles in the impact numbers, but it looks to me like most of these warheads are behaving roughly the same way. You don't see this erratic brightening and dimming, and the smearing out is due to the camera. Is partly due to the camera too, because the camera has a delay. It's over the focal plane array in the camera has a delay time in responding to the change in intensity.
Right. So I want to look at that. I want to zero in on the Nevatim airbase situation. So there were at least identified. Maybe there were more that weren't identified, but we saw 32 that were identified. And
32 impacts.
Do I understand correctly that you say that your best estimate is a 2.2 kilometer CEP?
It's a 1.1 kilometer. In fact, I had made a mistake. I forgot to divide by 2, and that's the only mistake I really made that nobody brought up.
Okay. All right. So a little over a kilometer CEP. What then would it take if they wanted to actually knock the airbase out or do some real damage? How many missiles would they have to fire, given that CEP, to actually cause serious harm to it?
Hundreds and hundreds and hundreds to do significant harm. Hundreds. And we'll talk about that. I mean, we can talk about that. Let me see where I am here, and let's take a look at attacking the Nasrallah, the attack on Nasrallah, where Nasrallah was killed. If we go to slide 43, we can. This is the area that was hit. The two buildings that are in that circle were over the shelter that Nasrallah, the Nasrallah shelter was under these two buildings. So, as you may recall from our discussion, those buildings had to be cleared away, because if you're coming in with a warhead, you can't just pass through the building and detonate. It's just not possible. So you have to clear the buildings away. And what the next slide shows is what that area looked like after the multiple waves. They just cleared the buildings away, and there had to be 2 waves or 3 waves. First, they splintered the buildings. They just demolished the building. They didn't hit these buildings with 1 or 2 2,000-pound warheads. They just smashed these buildings to smithereens. So they could have had 5 or 10 2,000-pound warheads just to just create a layer of rubble that's basically on the ground. Not many large pieces, just turn the building into small pieces of rubble, all lying on the ground. So the next things that hit the ground are close to hitting the ground and penetrating the ground and then detonating. And I didn't have time. I saw some, thanks to Gary, some nice images of holes that were dug in the ground, but I didn't have a chance to put them into this briefing, as I just only had so much time traveling and everything. But what they clearly did was they dumped between 80 and 90 2,000-pound bombs in 2 or more waves. My guess is it was more than 2 waves, but demolishing the buildings. And I mean, when I say demolishing it, I'm saying not destroying the building where you can see hulks of the building, turning the building into small pieces of rubble that are lying on the ground that will not cause the pre-detonation of warheads that are going to come in and try to penetrate the ground to get at that underground shelter. Yeah. And you can see evidence of deep holes there. I mean, they just turned the place into rubble. That's a great photograph. You got it. You're a good straight man, Gary. And, so
you're a good leader. You're a very good leader.
So this was done in multiple waves, and you can see that other buildings next to it were also very severely damaged, but you couldn't use those buildings, but they weren't turned into just shrapnel, which is what was done in this case.
So, but now I think I saw on your diagram that was a 100-meter CEP missiles. You think those 2,000-pounders?
They were probably 10 meters or 5 or 10 meters each.
Okay, so that took.
They probably delivered them with a precision of 5 or 10 meters each.
So if that was
those were laser guided bombs.
Okay, so if we're seeing something that's that precise here and it still took 85 to 90, then if you're talking more than a 1 kilometer CEP from the Iranian side on a base, not just a specific target, I mean, they would have to have large numbers. I guess that's true.
Yes. So if you look at slide 46, I don't mean, I'm sorry to write an equation, but people who want these things, I'll send them the slides. So if they want to do harm to themselves and work on that, that's okay. This is just a very simple probabilistic expression that I can send the derivation for it that uses the CEP. And it basically says that if I want to get the probability of landing within a circle, in this case, the CEP would be 1,000 meters. And the radius of the circle would be 50 meters. And the size of the area that I'm trying to hit is 100 meters across. So I can treat that area as a lethal area, an area where I want to place a warhead. So I'll say place it within that area. I'm not, where I place it in the area, I don't have any control over, because I don't have 5 and 10 meter CEPs like were delivered from these airplanes. So I just want to place a warhead in that area. So the arithmetic would be R sub L would be 50 meters and the CEP would be 1,000 meters. So if we go to the next slide, not the next, I just do the arithmetic for, in this case, I chose 100 meter CEP, a very accurate CEP. And in the case, this is a Trident 2 accuracy. And if you look at the arithmetic at the end, I get a 0.16 chance of a missile landing within that 100-meter area. So if I want, if I send 10 of these missiles in with that accuracy, with 100-meter accuracy, I'm going to maybe hit, I'm maybe going to have 2 or 3 missiles hit within that area. Not all hit within the center of the area as happened, but that's the best I can do with that kind of accuracy. And if I have less than, 100, it's going to be, I'm going to have thousands, one chance in 1,000. So if I go to slide 48, I do some more arithmetic there. If the next slide, the yellow row in the matrix shows that if I have a 50-meter accuracy, so I'm saying I want to place the warhead somewhere within that 100-meter diameter area, and I have 1,000-meter CEP, my probability is going to be 1 in 1.7 thousand of placing one of the missiles in there. So if I have 180 missiles, if you look at the next lower equation, and I use all 180 missiles to try to place them into that 100 meters diameter circle, I'll have a 0.3 chance of doing it. I mean, I'll have 1 in 3 chances with the 200 odd missiles will result in one of these 1,000 meter missiles hitting inside that. So this is not a weapon that's going to be useful.
Yeah, so it's just an area. Really, right, against a hardened target or something you like with Nasrallah. If you want to take him out, those are not the weapons to use. But if you were, and they haven't done this so far, but if they wanted to, if they just wanted to, like, say, we're going to take, a center mass on Tel Aviv or on Haifa or some other city, then there could be a lot of damage, because wherever it lands, it's going to hit something.
Yeah. So if you look at slide 50, 50, I've done this is a random, this is Washington. It's just I had it. And what I've assumed is
a 5. My house, I see there. What? Oh, anyway, sorry.
It might be. I don't know your address yet.
All right, I just wondered. Anyway, sorry, go ahead.
Don't give it to him. Don't give it to him, Danny.
No, I ain't going to, man.
Yeah, I'll use a cruise missile, one of those homing. So what I've shown is the 5 pound per square inch contours and 100 meter CEP. And I had a bunch of warheads I threw in there. And you can see many of them are overlapping. So I don't get the full benefit of the area that I'd like to cover. So in other words, I have to take account of the fact that some warheads, this is exactly the effect that people were seeing at the airbase. Sometimes things clump together, sometimes not. This is a random effect due to the random statistics of the situation. So if I go to slide 55, I think, I'll just, I wrote down an arithmetic expression for the fraction of a bombed area covered with a given level of blast or higher. That's this 1 minus E with this number N, which is the number of warheads And the delta A over there is the area of blast covered to a given level. So if I want to get an estimate of the size of the area, I just go to slide 52. Let's go to slide 52. And I say, oh, if I want to have 40 pounds per square inch on the target, then the range at which I'm going to have to, the lethal range is going to be 30 meters. So it's at the 20, 30, 40 meters. If 5 pounds per square inch are enough, because I'm just going after Dan's house, then the blast range is 150 meters. That'll be enough. And that'll be enough to knock down the house and, teach him a lesson or two. But so that you can think of the areas, these little delta A's that I've manufactured, these mathematical assumptions as estimates for the size of area subjected to a given blast or more. So like it's 5 pounds per square inch or more. So if we go back to slide 55, and I say I have, I cover the area, the entire area completely. I have whatever the fraction of area I cover. So let's say I can cover 1,000th of a square kilometer with blast, and I put 1,000 warheads into the square kilometers. I'll cover 63% of that area with that level of blast. So there'll be 36% of that area that I don't actually hit. Now, does it mean it's not damaged?
In terms of what's effective, so these types of missiles are just area weapons, almost like artillery.
Right, area weapons.
And what kind of targets would be? I mean, other than, and maybe not even other than, maybe is it just built up areas in cities?
Yeah. You would use them as a terror weapon against built up areas, or if there's a military installation that's big and it's got a lot of not very hardened targets, but most airfields are not those installations, because airfields are, and that's why I'm also saying, I also say, everyone's worried or talking about Israel going after the Iranian nuclear facilities. They're not going to. You can't get these things. They're underground. The damage radii, are going to be infinitesimal.
So now, tell me also, if these, with all that calculations you just made, if you're talking about, let's say, for example, Israel right now, according to reports, has 4 combat divisions fighting in southern Lebanon. You could probably take the ground targets, which obviously would be much more much less defended, and that could potentially harm the ground troops if they're concentrated. Is that true?
Yeah, you could potentially, but even that would be difficult, because if the ground troops were alerted to the arriving warheads and they just got on the ground, didn't even take shelter, the lethal radius against them would collapse. If you're doing arithmetic with these kind of weird statistical equations I'm writing down, you have to associate a lethal radius with an individual. In other words, a vulnerability area. Well, that vulnerability area might be tens of meters if a warhead lands close to them and they're standing, or a meter or two if they're lying on the ground and the warhead's not very big. That's why you have so few casualties from the Scud, from the ballistic missile attacks coming from Gaza, because the Israelis are told to take shelter, and they're given warning of the arrival of, they're given sometimes only a few minutes if they're close in, sometimes several minutes if they're in a place like Tel Aviv relative to Gaza. So in World War II, the buzz bombs were flying into London, and they had about a 1-ton warhead. These were like little earliest kind of cruise missiles. They were not precise at all, maybe land in a plus or minus a mile of the target they were aiming at. And what people would just go about their business after they got used to the buzz bombs coming in, and they were called buzz bombs because you could hear the pulse motor, a very primitive kind of jet motor that would just make a buzzing sound. And when the motor shut down, the tail fins of this flying bomb would turn downward and cause the buzz bomb to go into a dive straight into the ground. You would have about 7 seconds between the motor turning off and the warhead hitting the ground. It was 1,000-pound warhead hitting the ground. If people were told to lie down in the street when they hear that motor go off, the casualties from buzz bomb casualties relative for people who got down in the street were 40% those of people who didn't get down, just randomly. 60% got killed anyway because they were too close. But there was a 1,000-pound warhead, 150 meters away from a 1,000-pound warhead, you can easily be killed. A lot of shrapnel flying and things like that.
So Ted, let me ask you in the last few minutes we have here, from what could come next, to what extent would the Iranians be able to, because I know you've talked in our previous episodes about that they do have some cruise missiles which are very precise, and some of these drones that are also can be precise if they get through. Could they saturate a certain area with ballistic missiles and some of the cruise missiles designed to hit at the same time so that they couldn't really defend against all of them, then the cruise missiles would get through? Is that a big risk for Israel if Iran wanted to hit a precise target?
I think that the big problem, and it is a problem I think they're going to face, is the cruise missile drone attack, the mixed attack of cruise missiles and drones. You can't ignore a drone, even though it's a simple vehicle, because it can do homing and it carries a 100-pound, 200-pound warhead. It'll home on your radar and destroy it, or home on your missile launcher if it's going after your air defenses. So you have to fire an interceptor against it. So what I do is saturate your defense with these cheap drones, which can travel 1,000 kilometers and home in on various air defense assets, forcing you to shoot at them, which is what the Russians did in Ukraine. Then you have the more sophisticated and expensive cruise missiles, which are harder to intercept because they have a lower radar cross-section, and they're coming in faster, but they also have homing. And you have them come in after the interceptors have been, exhausted. So I think the problem that the Israelis are likely to face is an exhaustion attack where thousands and thousands of these drones are sent in, mixed with cruise missiles, and they're going to have to choose what to shoot at and what not to. And they're going to have to shoot at a lot of these things and they're going to just run out of interceptors. That's why I think you saw almost no interceptors in the air shooting at ballistic missiles, because they're saying to themselves, why make believe I'm going to hit a ballistic missile when I have almost no chance of doing it? Let me save that interceptor for a drone or a cruise missile, because an Iron Dome against a drone or a cruise missile is going to have a pretty good chance of intercepting it. They're traveling slowly, 200 miles per hour if it's a drone, 150 miles per hour. If it's a cruise missile, 400 miles per hour, 500 miles per hour. That's a pretty competent target for an air defense interceptor like the
let me add the final question I have here, and this may be a policy issue, like a decision, and maybe it's outside of your area of expertise, but I thought I'll ask anyway. We are likely, we could literally be days or even hours away from when Israel's going to launch its response to the 180 missiles that came from Iran last time. And Iran has already signaled it's basically waiting to respond. It's going to do some version probably of what you said right there. Do you think that if whenever Israel does launch whatever it's going to do, and if it even goes after some of these nuclear facilities or energy infrastructure, et cetera, do you think that Iran will wait until all that lands, or do you think that they will strike while maybe even the missiles are passing each other in the air? How do you see that?
I think they'll wait. They'll wait. They'll plan their attack. They'll do a damage assessment, get a sense of what Israel tried to do, and decide whether it's a complete escalation or a modest escalation. This is going to play out over a good deal of time, and I think Israel comes out on the bottom no matter what, because it's going to be possible to exhaust the air defenses and do a significant amount of general damage with cruise missiles and drones.
Can either side knock the other out with missiles?
What?
Can either side knock the other out with missiles?
I think you just need a lot of ordnance to truly level a place. And aircraft are the only things that are capable of doing that. And air defenses tend to preclude that kind of mass attack. I mean, if the Israelis want to send their air force over Tehran and try to level the place, they're going to lose a lot of aircraft. Those air defenses, modern air defenses, are very good against airplanes. They're not at all capable against ballistic missiles, but the ballistic missiles, they're not that accurate. They don't carry tremendous payloads. But airplanes, carry a lot of payload. And if they're allowed to work without air defenses, blunting them, they can do a tremendous amount of damage. That's what's happening in Ukraine. In Ukraine, the Russians have basically exhausted the Ukrainians' ability to use air defenses, either by destroying the air defenses with drones and cruise missiles, or ultra accurate Kinjal missiles, because the Kinjals are ultra accurate. They seem to have very high precisions, like tens of meters. It appears that way, at least. And so you can use a ballistic missile with that kind of precision, but that's not available to the Iranians, and I doubt it's available in large numbers to the Israelis as well. I mean, they can in principle build high precision, longer range missiles in the 1,000-kilometer range. They may even have some. I haven't looked at their arsenal in any great detail, but I doubt they have thousands of them like the Russians have.
Yeah.
So it's going to be a wash.
Yeah, that's what I fear. Just not a lot of no decision can be reached. They can kill lots of people, blow a lot of stuff up, but at the end of the day, I don't see it reaching.
It's going to be a pointless slug out, loss of human life, all basically brought about by the aggressive posture of Netanyahu and the failure of the United States to rein him in.
Yeah, I think.
I mean, that's a policy statement, but
yeah.
I mean,
a lot of evidence to support that.
Get away from it, it's and he's going to have a real problem. He's going to, as you know better than I do, you're a soldier. He's got the shock effect of killing a bunch of the leadership in Hezbollah. Hasn't had any real effect on the soldiers. They're
fighting. Yeah,
these guys got nothing to lose, and as long as they're trained well enough to know how to use small group tactics to be a threat to small groups of Israeli soldiers, it's going to be a slug out, and it's not going to be a cakewalk.
Nope.
As long as these guys are willing to fight and stay at it.
Well, listen, Rick, always appreciate you coming back on, especially taking your time out of this trip you had to Berlin already to come and talk to us about this today. Who knows? We'll probably be having you back on pretty soon, because the next round could be coming any time now.
Well, I hope some of your questioners at least think they don't know quite as much as they seem to have thought they do. At least I hope so, but it's a complicated situation.
No doubt about it.
It's hard to
thank you very much for coming on. We really appreciate it. And we appreciate all you guys coming on with us too. We always value your input, and we're always watching your comments. We're going to be coming back to you tomorrow. We're going to have the the weekly intelligence brief. We're going to have that updated for you tomorrow, because I know a lot of you can't see every show here, but we want you to get the highlights of the week. We'll be showing that to you tomorrow. And we always we typically do. We'll have some great guests for you next week. But in the meantime, be safe out there, and we'll look forward to seeing you on the next episode of Daniel Davis Deep Dive.